Alright, so number 5 says to sketch a force diagram for each of the objects below. Write an equation for the sum of the forces in both the x and y directions. So for the first one, you know that there's going to be two force diagrams because there's two objects. So the first object that I'm going to be doing is going to be the big box, which is the 15 one. So, sorry, that's a 5. Okay, so you start off by drawing your circle or whatever you put as the main point. Then you have your force normal because the platform or the table base thing is pushing up. And then you're going to have force gravity because there's always force gravity on an object. And then a force tension because of the pulley. And then you know that the equation is going to be that force normal and force gravity are going to be equal to each other. They're going to be the same. But then, since that the system is accelerating, as it states in the question, that force gravity is going to have to be more than force tension, and the force tension is going to be more than the force friction. And then for the second object, you're going to draw your base again, which the second box, the only two forces that it has is force tension from the pulley pulling it up, and then force gravity pulling it down. And then you know that these are going to be equal, so it's going to be force tension equals force gravity. Okay, so then the second set of force diagrams is, it says the box is motionless on a ramp thing. So you know that the box is going to be kind of on a diagonal. So you're going to have force normal pointing up because of the ramp pushing it up. Force gravity is going to be slanted, and you're going to break it up into horizontal and vertical. And it's going to be at a 15-degree angle. And then your force friction is going to be pushing the opposite way because it's motionless. So these two have to be equal. Which then sets us up for force normal equals force gravity x, and force friction equals force gravity y. Okay? And then the third force diagram would then be, this says that it appears to be that the friction is 0 and it's being pulled at an angle. So you're going to have the force gravity pointing down and force tension at a slant, and you're going to break it up again to this be 20 degrees. So then you know that your force gravity and your force tension y are equal, and then the force friction would have to be less than the force tension x.